Hi everybody, welcome to another video about, welcome to another video about LangChain and this is a continuation of the previous one that I made about LangChain, this project that I called LangChain Real Analysis Helper. So let's refresh our memory on what the point of the project was. So I found these web pages, these HTML web pages about real analysis, and I wanted to create an LLM, an RAG or RAG pipeline, retrieval augmented generation. I think that's what it stands for, to allow a user to interact, to ask questions about these web pages, and to get answers out. And I wanted to see what the power of this was, like whether I could combine this information that is contained here. Like I wanted the information to clearly come from here, but I also wanted the LLM to be able to interpret the information and like provide proofs that aren't that are based on this information, but that aren't directly in the information. At least I wanted to see that hypothesis. I wanted to test if that could be the case. So um, this is I've built some LangChain things in the past, and this is sort of the next step. This application of getting documents, getting some data from somewhere and then answering questions based off of it is a really important application of LLMs, especially to companies that want to build LLMs for engineers and for their employees to use. There are many thousands of internal documents that companies generate every day, and it would be very nice if you could have an LLM that has them all, knows all the documents, and the engineers or employees can ask questions to the LLM about about the information contained in these various documents. So I wanted to build, like I said, a sort of a very similar or a prototype of this kind of pipeline. So here's my data set. I have these 4 HTML files. I did need to convert them to UTF-8 because unfortunately when I just curled the HTML files, they were in an encoding that it wasn't good enough for Beautiful Soup. There were some characters in there that were non-UTF-8, and Beautiful Soup was complaining about them, so I did have to convert them to UTF-8. All of this downloading happens in the container file. So as the container file is getting generated, so this will make it, this is like it's really standalone execution. So you just the hope is that like all of the execution, this entire sort of application is nicely packaged into a container. But anyway, I'm getting a little bit ahead of myself. So let's talk about what it takes to implement one of these systems. So, like I said, here's the code. So the execution of this application starts from the container file, right? So here's my container file. It's going to install the requirements. It's going to curl my pages. It's going to convert them to UTF-8. This is also in the script that I wrote here, where it converts them to UTF-8 encoding. And then it's going to run this LLM here, right? So a couple things, right? So like I said, this is a little bit different from the other LLM things that I've built in the past because there are documents here. And so here's the thing about documents, right? So LLMs, basically what an LLM is at its core is something to predict the next word in a sequence, right? And how can that be used? Well, if you ask it a question, then you can use the LLM to generate an answer to the question by predicting the next word in a sequence, given that the prompt is the question, right? Hopefully that makes sense. How does this apply here? So in order for the LLM to answer questions about real analysis, so this was something I did before. So you can put the information from the real analysis or from whatever source you want as context to the LLM before the question. So what will it look like? It'll look like the template, or what you give to the LLM to answer to predict the next token is something like this. You say context, colon, and then the context. And then after that, the question, colon, and then the question. And then the LLM will read the context, It'll read the question and it'll try to answer the question based off of the context. Does that make sense? Okay, good. So so that's what we want to do. How and what we certainly could do in this application. So these web pages are fairly small. So you can see there's only 4. I mean, I only loaded these 4 web pages and they're fairly small. So what I could do is I could load all 4 web pages, just stick them together, stick the strings together, and just provide it as context into the LLM. So the LLM, we got a prompt, it'll get the context, it'll get these 4 web pages, the text from all these 4 web pages, somehow extracted, and then the question that the user gives it, right? But that's not the way these pipelines are usually created, because I mean, this is only 4 web pages, but in an extreme case there could be many thousands of web pages, and the LLM actually has a limited context length, so you cannot put all the information into the context that you want ever. There is a limit, and it is probably also more efficient to give it a smaller context so that the LLM can better understand. I'm not sure about that, but certainly what you really want to do instead is create, or not create, but you want to retrieve the most relevant section of these web pages. So for example, if the user asks about equivalence of, let's just say the user asks, what is the definition of an equivalence relation, right? So this web page right here, absolutely useless to answer that question. This web page, also absolutely useless. But this one right here, specifically this section, this is the part that the LLM needs in order to answer that question, right? And it would be ideal if we could just retrieve just this section of the web page to help the LLM answer the question, right? Does that make sense? So how do we do this? It has to do with something called an embedding. So when we load all of this text, so here's the question. Let me just repeat the question. The question is, how do we help the LLM find the relevant part of the document to use as context to answer the user's question? Does that make sense? There could be many thousands of documents. The documents could be huge, and the context length of the LLM is limited. We can only fit so much into there. So we need to find the most useful the most useful context, the most useful documents to feed the LLM so it can answer the question. And in this case, it is this paragraph here. So the question is, how can we help the LLM find the most useful documents? And the answer to this is an embedding. So OpenAI provides embeddings, and embeddings are also part of LLMs, but that's not important. What matters is that when the user provides a question, that is a string. And so then we run it through an embedding to get a vector. And a vector is something like 1,500 numbers that encode the information presented in the string. So let me give you an example. Let me not give you an example first. Let me just give you an example of what these vectors are useful for. So let's just say we generate the vector, the vector embedding for the word apple, right? And then we also generate the vector embedding for the word orange, okay? These are kind of similar. So in our use case, like I said, we want to retrieve the document that is most similar to our user input, right? So let's just say the user input is give me an object that is similar to an orange, right? And then the answer to that question, which we hope to get, let's just say we provide a bunch of different type of objects, and one of them is apple. Okay, so apples are pretty similar to oranges, so we return, hopefully, the apple, right? I don't know if that's the most sort of clear example, but so let me get back to it, right? The point of this is to easily and quickly retrieve the most relevant piece of Yeah, so this quickness matters. So let me just repeat again. The point of this is to retrieve the most important document to answer the user's question. So here's what we're going to do. We're going to generate a vector for the user's question. We're going to generate a vector for all the documents, and then we're going to scan through all our documents or through a database of our documents that we prepared ahead of time, and we're going to say, can you retrieve me the document that has a vector most similar to the user question? And if we are able to do so, then we will return Apple. Then the LLM. So we will retrieve, for example, the 8 most relevant documents. So Apple will be in there. So Apple will be returned, and then the LLM then will the Apple document will become part of the LLM's context, and it will be able to use that information as relevant information to answer the user's question, which is give me a similar object to an orange, right? So in this example, let me just go back to this example. So if I, as a user, were to ask the question, what is the definition of an equivalence relation, right? So let's just say I have taken all these 4 web pages, which I have, and broken them down into chunks. Then I have generated the vector embeddings for each of these chunks, and let's just say this is one of the chunks. So then if we look at, if we pick out random chunks from these web pages, we can generate, we will generate a vector embedding for each of these. And our hope is that the vector embedding for this chunk right here is the one that is most similar to the question that I just asked, which is, what is the definition of an equivalence relation? Okay, so and this works. This works. This is how people usually do it. So so here's how we can sort of visualize the process, right? So we ask the question, and then the retriever will it is connected to a database. It will query the database for similar documents, and it will return me, for example, the 8 most similar documents. And then I can directly look at those, as an engineer, as an LLM engineer, I can directly look at those documents and say, we didn't find the document we were looking for here. Why? Or we can say, yeah, we did find the document we were looking for. And then the document, like I said, becomes part of the LLM context, and it helps the LLM answer the question, right? Because, like I said, this is the part of the web pages that the LLM needs to know to have in its context to answer the user question, which I just gave it, right? Hopefully that makes sense. So a couple concerns here. The chunks need to be big enough. They need to be big enough to store, not like they need to be big enough for the LLM to use them as context to answer a user question, right? If the chunks are, in the extreme case, 1 word each, that's not going to be helpful for the LLM to answer questions about user questions, right? Because 1 word doesn't give any sort of meaning, right? But again, we can't make the chunks huge, that big, because maybe they won't even they'll be too big for the context, perhaps, or certainly it's also very useful to return multiple chunks, right? If you make the chunks too big, then maybe you won't be able to return as many chunks for the LLM to use as context. So yeah, so they can't be too small, these chunks, but they also can't be too big. So you need to find a happy medium where it's a chunk, has enough context to understand what the chunk is trying to say, and it has enough context also to function as like an independent unit of information that the user will ask questions about, and then it will be retrieved, right? Hopefully that makes sense. So here, like I said, here we load the UTF-8 files that I generated in the Docker file. Then I split them up into chunks using this text splitter right here. So here's my chunk size, is 1,000 characters. And then there's overlap so that the chunks, they have a little bit of the previous chunk, so that maybe it helps with the context to understand like what is the purpose of this part of the text to the rest of the to the rest of the document or to other chunks, right? Like if a user asks a question and it requires several chunks in a row to answer, the LLM will be able to kind of put that information together, right? I mean, that's the hope. So, so then here's my chat OpenAI, and then here I use an LLM, a LangChain provided conversational retrieval chain. So I didn't realize this at the time, but this thing is really limited. And what I mean is that if the information is not directly found in the context, then this conversational retrieval chain will just ignore your question. It won't try to like generate something from what it already knows from the LM, from ChatGPT's power. It will just pretty much just give up. It'll say, oh, the question isn't found in the context, I can't really answer it. So this makes sense for a lot of applications where you don't want the LM to make stuff up about your documents, right? You certainly wouldn't want it to hallucinate and tell you wrong facts about your documents. You would rather just have it say, I have no idea what you're asking me, user. Please, please talk with the LM engineer. But in my case, I really, like I said, I did want it to generate some math proofs or something that weren't found. Like I wanted to synthesize math proofs and information from like multiple documents and create math proofs that aren't found directly in the text. So this is not a good fit for my project. Next time I try to write something like this, I will use a different LM, something that is less limited. So let's look at some of the examples which are generated on my GitHub here. So here, so let's look at this. So here I see this 1.4 point right here. So I wanted it to answer this question right here. So why would anyone bother introducing more complicated numbers, such as the real or even complex numbers? Find as many reasons as you can. I wanted to answer this question. The thing about this question is that the answer isn't found in the text, right? It's a question. It is a homework question from this website, and it's not found in the text. So, let's take a look at what happens when we ask that question. The text doesn't provide a specific answer to example 1.4.5. So you see, so the text, exactly as it says, this is what I was talking about, where this specific LLM chain is quite limited. It's not going to use its own, like if the answer isn't found directly in the context, it's not going to bother answering the question. So that's kind of, it's kind of bad for this use case, but good for other use cases, as I mentioned before. However, it did find, let me close this. However, it did find the right chunk. You see this? So example 1.4.5. So this is a good chunk, right? It has the example 1.4.5, right? So this is actually the most important document. So it does rank these documents by most important document. And this was the most important document that it found relevant to the question, which is fantastic. This is exactly what we wanted. So it has enough space for the example, and it has enough space also for the question, which is also ideal. It's fantastic. So here's the next thing. Another example, another question that I try to ask it. This time I asked something that was directly found in the document. Tell me what the definition of an equivalence relation is actually here. What are the three properties? And the answer I got back right here is the three properties are reflexivity, symmetry, and transitivity, which is exactly the same wording used. I mean, even the variables are the same in the answers that it gives. So that's certainly a great thing. I think if we were to look at the documents here, it would provide this data right here, this text, as the most important document to answer the question. This is sort of a success case, right? So we asked it a question. We know that the answer comes directly from, it was able to answer, and the answer comes directly from the text that we provided it. And then finally, I wanted to just to make sure that it really that it really answers questions only about the context which is given. I asked it a completely unrelated question, or a question completely unrelated to the context that I provided, the documents, right? Tell me about 3 different dog breeds. And the answer here is, I'm sorry, but the provided context does not contain any information about dog breeds, right? So what does this mean? Like I said, this specific chain, this specific provided LangChain chain is absolutely useless at answering general questions. It will not answer the question if the information isn't contained in the context. Yep, I hope you enjoyed this video, and I'll see you in the next one. Thank you.